In this video, we're going over the exam guide for the AWS Certified DevOps Engineer Professional certification. But before we jump right in, go ahead and subscribe to the channel right now. In this channel, I teach you AWS cloud computing best practices, well-architected tips, and help you up-level your tech skills. Let's jump in. So in this certification, you will validate your ability to automate, test, and deploy AWS infrastructure and applications in the AWS cloud. Let's talk about who this certification is for. This is intended for individuals with at least 2 or more years of experience provisioning, operating, and managing AWS environments. And before you take the exam, this is what AWS recommends you have: experience developing code in at least one high-level programming language, building highly automated infrastructure, and administering operating systems. You need to be able to understand modern development and operations processes and methodologies, the ability to implement and manage continuous delivery systems and methodologies on AWS, the ability to implement and automate security controls, governance, processes, and compliance validation, and the ability to define and deploy monitoring metrics and logging systems on AWS. Now let's look at some of the particulars over here. The length of the exam is 180 minutes to complete. That's 3 hours. This is a hefty exam. The cost to take the exam is $300 US. So when you go to schedule this thing and take it, you don't want to fail this thing. You really want to be prepared. $300, at least from my standpoint, that's a lot of cash. But I'll tell you this, once you pass this exam, that really opens up a lot of job opportunities for you and just gives you a wealth of knowledge to help you be more effective on the job. There's going to be 75 questions on the exam, and it's going to be a mix of multiple choice and multiple response. Now, let's go into the fun part, the exam guide, or what I like to say, the blueprint. Now, with any certification exam you take, in this case, AWS, or any certification exam for that matter, you really need to know what you're up against. And these AWS exam guides really break down the material for you. Now, they're a bit long and lengthy, but and maybe not the most exciting material, but they're going to really tell you what's expected of you so you know how to spend your time and energy to study. So that's very important. Let's jump in here. And there's a little bit of overlap sometimes in the exam guides as well as that landing page. So let's see here. Well, yeah. Exam validates the candidate's ability to implement and manage continuous delivery systems and methodologies, implement those security controls, governance and compliance validation, define, deploy, and monitor metrics and logging systems, implement systems that are highly scalable, available, and self-healing. And you need to be able to design, manage, and maintain tools to automate operational processes. There's some overlap here a little bit with the professional solution architect associate, but the DevOps engineer really focuses a lot on that software development lifecycle and the automation of deploying code out into production and kind of that whole process workflow. Now, let me jump into what is considered out of scope for this exam. You're not going to need to know advanced networking. You're not going to need to know deep-level security recommendations for developers. You're not going to get into database query and performance optimization from a database perspective. Full-stack application code development. You're not going to be writing code in the exam. You're going to basically be given a requirement as if you were a DevOps engineer and be able to employ DevOps methodologies and best practices to accomplish that task that's outlined in those scenarios and those questions. And you certainly don't need to normalize any data schemes in here, completely out of scope. One thing I wanted to point out is, like most AWS certification exams, this one's no different. There are going to be 10 unscored questions on here that do not affect your score. The trick is you're not going to know which ones. So out of those 75 questions, 10 of them are kind of like unscored / experimental. Do your best on all the questions, but you can miss 10 of these experimental ones and still be okay. The score ranges range between 100 and 1,000. If you get a 100, you're definitely not going to clear the exam. To clear it, you need a minimum passing score of 750. So that's not too bad. That's like a 75 if you look at it, which is certainly doable. Now, let's jump into the domains. You have 6 domains here. SDLC automation, software development lifecycle automation, is 22%. Domain 2, configuration management and infrastructure as code, 19%. Domain 3, monitoring and logging, 15%. Domain 4, policies and standard automation, 10%. Domain 5, incident and event response, 18%. And Domain 6, high availability, fault tolerance, and disaster recovery, 16%. So for the most part, there's an even spread here. The first 2 domains are a little bit heftier than the others. And then Domain 4, policies and standards automation, coming in at around 10%. Now, stick with me here now. If you need to pause this and get a drink of water, do so. Also, if you haven't subscribed already, go ahead and subscribe. And what I want you to do is, in the comments, I want you to say, I subscribed. When I see that in the comments, I'm going to jump on the comment. I'm going to reply back to you, and I'm going to let you know I see you, all right? I see you. We're connected. All right, Domain 1. Hang in here with me now, because this stuff's important. You want to be prepared for your exam, and that's what I'm going to do for you. SDLC automation. Bullet point 1.1. Apply concepts required to automate CI/CD pipeline, set up repositories, set up build services, integrate automated testing, set up deployment products and services, and orchestrate multiple pipeline stages. Bullet point 1.2. Determine source control strategies and how to implement them. Determine a workflow for integrating code changes from multiple contributors. Assess security requirements and recommend code repository access design. Reconcile running application versions to repository versions. Differentiate different source control types. 1.3. Apply concepts required to automate and integrate testing. Run integration tests as part of code merge processes. Run, load, stress test, and benchmark applications at scale. Measure application health based on application exit codes. Automate unit tests to check, pass, and fail code coverage. For example, using services like Code Pipeline and Code Build. Integrate test with pipeline. Now, this should sound very familiar, in particular if you are a developer or if you are a solution architect and you work with developers on a daily basis in your interactions. If not, then you might want to brush up on software development life cycle kind of best policies and procedures, okay? Bullet point 1.4. Apply concepts required to build and manage artifacts securely. Distinguish storage options based on artifact security classification. Translate application requirements into operating system and package configuration. Determine the code environments, dependencies, and required resources. For example, code deploy AppSec, code build build spec, and run a code build process. Bullet point 1.5. Determine deployment and delivery strategies. For example, AB, blue-green, canary, red-black, and how to implement them using AWS services. This is very, very important stuff when you're trying to determine how you should roll out your releases into the production environment. And once you know this stuff, it's really going to help you in your DevOps engineer role. Determine the correct delivery strategy based on business needs. Critique existing deployment strategies and suggest improvements. Recommend DNS routing strategies. For example, Route 53, Elastic Load Balancer, Application Load Balancer, based on business continuity goals. Verify deployment success and failure and automatic rollbacks. Moving on to Domain 2, configuration management and infrastructure as code. Be able to demonstrate knowledge of process flows of deployment models. Given a specific deployment model, classify and implement relevant AWS services to meet requirements. Given the requirement to have DynamoDB, choose CloudFormation instead of OpsWorks, and also be able to determine what to do with rolling updates. Bullet point 2.2, determine application and infrastructure deployment models based on business needs, including balancing different considerations, cost, availability, time to recovery. Building in the cloud is all about trade-offs, or building anything in general is all about the balance of trade-offs based on business requirements to choose the best deployment model. Determine a deployment model given specific AWS services. Analyze risk associated with deployment models and relevant remedies. Bullet point 2.3. Apply security concepts in the automation of resource provisioning. Choose the best automation tool given requirements. Demonstrate knowledge of security best practices for resource provisioning, such as encrypting data bags and generating credentials on the fly. Review IAM policies and assess if sufficient but least privilege is granted for all life cycle stages of deployment. Review credential management solutions such as EC2 Parameter Store and as well as third-party. Build the automation, CloudFormation templates, chef recipes, cookbooks, code pipeline, and etc. Bullet point 2.4. Determine how to implement lifecycle hooks on deployment. Choose appropriate integration techniques to meet project requirements. Choose the appropriate hook solution. For example, implement leader node selection after a node failure and an auto-scaling group. Evaluate hook implementation for failure impacts. If a remote call fails, if a dependent service is temporarily unavailable, for example, Amazon S3, and recommend resiliency improvements. Evaluate deployment rollout procedures for failure impacts and evaluate rollback recovery processes. Bullet point 2.5. Apply concepts required to manage systems using AWS configuration management tools and services. Identify pros and cons of AWS configuration management tools. Demonstrate the knowledge of configuration management components and show the ability to run configuration management services end-to-end with no assistance while adhering to industry best practices. There's a reason why this is a professional exam. Again, you have to dive deep to be able to pass these. Moving on to domain 3, monitoring and logging. Always very important in your actual production environments, as well as your lower environments. Anything you're paying for and deploying into AWS, you need to be able to monitor and log on that workload. Bullet point 3.1, determine how to set up the aggregation, storage, and analysis of logs and metrics. Implement and configure distributed log collections and processing. Agents, syslog, Flumed, CloudWatch agents, etc. Be able to aggregate those logs. Amazon S3, CloudWatch logs, intermediate systems such as EMR and Kinesis Firehose and Transformation and Elk stacks. Implementing custom CloudWatch metrics, log subscription filters, managing log storage lifecycle for CloudWatch S3, S3 lifecycle, and S3 events. Bullet point 3.2, apply concepts required to automate monitoring and event management of an environment. Parse the logs, Amazon S3 data events and event logs, ELB logs, ALB logs, CloudFormation access logs, and correlate that with alarms and events. Use CloudTrail and VPC flow logs for detective controls. Configure and implement patch, inventory, state management, ESM, SSM, inspector, code deploy, OpsWorks, and CloudWatch agents. EC2 retirement and maintenance. Handling scaling failover events. Determining how to automate the creation of monitoring. Again, a lot of stuff going on here in logging and monitoring. Bullet point 3.3. Apply concepts required to audit, log, and monitor operating systems, infrastructures, and applications. You need to be able to monitor end-to-end service metrics, DynamoDB and S3, for example, using available AWS tools, X-Ray, Elastic Beanstalk, and Lambda. Verify environment and OS state through auditing, inspector, config rules, CloudTrail, process and action, and AWS APIs. Enable, configure, and analyze custom metrics, application metrics, memory, Kinesis client library. Ensure container monitoring, task state, placement logging, port mapping, load balancing. Distinguish between services that enable service level or OS level monitoring. Bullet point 3.4, determine how to implement tagging and other metadata strategies. Segregate authority based on tagging, such as lifecycle stages, dev and prod, with condition context keys. Utilize Amazon S3 system user-defined data for classification and automation. Design and implement tag-based deployment groups with code deploy. And know about best practices for cost allocation and optimization tagging. Domain 4, policies and standards. Bullet point 4.1, Apply concepts required to enforce standards for logging, metrics, monitoring, testing, and security. Detect, reporting, and respond to governance and security violations. Apply logging standards across application, operating system, and infrastructure. Apply context-specific application health and performance monitoring. Outline standards for delivery models for logs and metrics, JSON, XML, and data normalization. Bullet point 4.2, determine how to optimize costs through automation, prioritizing automation effort to reduce labor cost. Implement right sizing of the workload based on the metrics. Assess ways to improve time to market through automating process orchestration and repeatable tasks. Diagnose outliers to determine use case fit. For example, configuration drift. Measure and automate cost optimization through events. Example, trusted advisor. Bullet point 4.3, apply concepts required to implement governance strategies. Generalize the governance standards across your entire CI/CD pipeline and outline and measure the real-time status of compliance with governance strategies. Report on those compliance and governance strategies and deploy governance policies related to self-service capabilities. Domain 5, incident and event response. Bullet point 5.1, troubleshoot issues and determine how to restore operations. Given an issue, evaluate how to narrow down the unhealthy components as quickly as possible. Given an increase in load, determine what steps to take to mitigate the impact, and determine the causes and impacts of a failure. Example, deployment operations. Determine the best way to restore operations after a failure occurs, and investigate and correlate logged events with application components. For example, application source code. Bullet point 5.2, determine how to automate event management and alerting. Set up automated restores from backup in the event of catastrophic failure. Set up methods to deliver alerts and notifications that are appropriate for different types of events. Assess the quality and actionability of those alerts. Configure metrics appropriate to an application's SLAs and proactively update limits. This is like a very mature, cloud-optimized, cloud-native DevOps strategy. This is what great looks like. Bullet point 5.3, apply concepts required to implement automated healing. Set up the correct scaling strategy to enable auto healing when a failure occurs. Use the correct rollback strategy to avoid impact for failed deployments. Configure Route 53 to ensure cross-region failover, and detect and respond to maintenance or spot termination events. Bullet point 5.4, apply concepts required to set up event-driven automated actions, including configuring Lambda functions or CloudWatch actions to implement automated actions. Set up CloudWatch event rules and or config rules and targets. Use AWS Systems Manager or AWS step functions to coordinate components. Configure a build rollout process to automatically respond to critical software updates. All right, domain 6, home stretch. High availability, fault tolerance, and disaster recovery. Straight out of things you would find in a well-architected framework. Bullet point 6.1, determine appropriate use of multi-AZ versus multi-region architectures. Determine deployment strategy based on high availability and disaster recovery requirements. Determine data replication strategy based on cost and durability requirements. Determine infrastructure, platform, and service-based HA and DR requirements, and design for high availability, fault tolerance, disaster recovery based on service availability. Bullet point 6.2, determine how to implement high availability, scalability, and fault tolerance. Design, deploy strategies to support HA and fault tolerance and scalability. Assess statefulness of application infrastructure components and use load balancing to distribute traffic across AZs, auto-scaling groups, instance types of different instance families. Use appropriate caching solutions to improve availability and performance. Bullet point 6.3, determine the right services based on business needs. Recovery time objectives, recovery point objectives, and cost as an example. Determine cost-effective storage solutions for your application, tiered archival, EBS type, Elastic Block Store, hot and cold, and those types of things. Choose a database platform and configuration to meet business requirements. Choose effective compute platform based on business requirements. Choose a deployment service and model based on business requirements. Go deploy, blue-green deployment, etc. Determine when to use a managed services versus self-managed. For example, Docker on EC2 versus the Elastic Container Service, just as an example. Bullet point 6.4, determine how to design and automate disaster recovery strategies, automating failure detection, automating components and environment recovery, choosing appropriate deployment strategy for environment recovery, and designing automation to support failure in hybrid environments. Bullet point 6.5, evaluate a deployment for points of failure, determine the appropriate deployment-specific health checks, implement failure detection during deployment, implement failure event handling and response, and ensure that resources, components, and processes exist to react to failures during that deployment. Look for exit codes on each event of the deployment and map errors to different points of deployment. Wow, we are at the appendix. 6 domains of glorious DevOps engineering. You will have your work cut out for you. But like I say, going over that exam guide is step 1. I hope you enjoyed this video. I hope it was very informative for you. Again, go ahead and subscribe. Make sure you comment below, leave your feedback, ask me any questions. I thank you for your time and attention, and I'll see you in the next video. Take care.